of frictions. What are they? Static friction and sliding friction. In this, if one object kept on surface, so it is having a static friction. Is it right, children? This is static friction. When it comes to the sliding, the same thing. Take one slide. You kept one of the object on it. It's ready to come to slide. So this time first it had the static friction. Then it comes to the motion. It is having now what type of friction? Sliding friction. That means the object is come to here, slides, then after it reaches the ground. So what I mean to say that these two types of frictions are interchangeable. Static friction is going to be changed as sliding, or sliding friction is going to be changes as static friction. So now coming for the next type of friction, rolling friction. Rolling friction. For this, I am giving a day-to-day life example. Okay, gas cylinder. If you want to shift, that is two way, no. You won't shift from one place to other. What you will do? Just like you are dragging. That means if you are dragging like this, it is difficult to pull it. So, for the same cylinder, if you arrange rollers under these rollers, then we can easily move with the help of rollers. What's the difference in between these two? First, without rollers means this contact area is more. So, when we arrange rollers under this, the rollers contact area is contact with the cylinder. So, that time the area will be less. So, by arranging of rollers, we can avoid the friction and we can easily pull the cylinder. Not only for this, but trolleys also. You can see in the railway station or somewhere heavy suitcases. If you are carrying, means it's giving so hectic for us. So what we will do nowadays, trolleys are came. That heavy box will have some trolleys, some wheels under that. With the help of wheels, the wheels are come to rolling. Then we can find out easily the man can pull the trolleys. Now I am going to explain the last type of friction. What is a fluid friction? What is mean by fluids? Fluids are nothing but liquids and gases. Means the liquids and gases can move from one place to another. Then these are called as fluids. So for this explanation, I need to take one example of one activity. Take one glass filled with water and add 1 spoon of sugar, then stir it with a spoon. So while you are stirring, along with stirring, the water is also comes to boiling. So then you stop that. What you have to stirring is stop that. Then you are finding the water also after some time comes to rest. Here, who stops that? The boiling, who stops that? Then we come to the concept of the friction. Friction is what opposes the motion. So while you are stirring, the water comes to the motion. Then opposes force. What is that? Fluid friction stops the boiling of water. So this is nothing but called as fluid friction. This fluid friction we can find out in liquids and gases. So we will take one more example. Birds are flying in the atmosphere, in the sky. So what you are thinking that the birds are moving with a short beak, like aeroplane also. At the same time, the birds having the wings. Is it right, children? So, when it comes to the motion, the air is also possessing somewhat of the force. So, to avoid the friction force, the birds make their body to finishing like a big shape.
Let's say you have this cuboid shaped box placed on the table. Try pushing it a little. You will require some force to push it forward. Now place this same box on top of cylindrical shaped pencils and push it. What do you notice? You will notice that the force required by you to push it to the same point as before will be lesser. Why is that? Do the pencils reduce the friction between the box and the table? Absolutely. But it's not about the pencils, it's about the shape of the pencils. They are cylindrical. Assume you are traveling to another city and you are carrying luggage weighing around 25 kilograms. If you're unable to carry the bag, the only option you have is to drag it on the floor. But you will still require a lot of effort to drag your bag. But what if your luggage had wheels under it? Won't it be far easier to carry it around? Yes, it'll be easier. But the question is why? Why is it easier to roll a box over cylindrical pencils relative to pushing it on a flat surface? Why is it easier to carry the bag around when it has rollers under it? Hold on to this thought. I'll come back to it. Before we discuss the above situations, we need to understand what sliding friction is. The concept is simple. It is the frictional force which opposes the relative sliding motion between the two surfaces in contact. What does this mean in simple words? It simply means that if an object is in motion on a surface, the frictional force that is offered by the surface is called the sliding friction. The key words here are sliding motion. The two surfaces have to be in relative motion with each other. In our example, when a box is moving on the table, we say that the box is in relative motion with the table. The resistive force applied by the table when the box is moving is called sliding friction. Remember, the objects have to be in relative motion. Because there's movement involved, this force is also called kinetic friction. Now consider the example of the luggage in which we don't have the wheels under it. When we move the luggage, what will the resistive force applied by the ground be called? Yes, sliding friction. But what happens when we attach circular wheels at the bottom of the luggage? Yes, the friction gets reduced to a great extent. This type of friction which arises when an object is rolled on a surface is called rolling friction. It is a force associated with rotational movement. Now can you tell me by pure intuition about which force will be lesser? Sliding friction or rolling friction? Yes, rolling friction is usually lesser than the one associated with sliding friction. And that's why attaching wheels at the bottom makes it easier to move the object around. And similarly, moving the box on top of the cylindrical pencils is also easier. Can you think of more examples where the concept of rolling friction is used to reduce the friction? Yes, tires of your car. When the car is in motion, the ground applies a force of resistance which is nothing but rolling friction on the tires. Do you remember seeing ball bearings? They are spherical metal balls used in many mechanical structures which have moving parts. They're generally made up of stainless steel, brass or ceramic. They reduce friction to a great extent, which in turn reduces the wear and tear of machine parts.